Hello, welcome to Chemistry by Ogres for Ogres and students. What we're going to talk about today is platinum metal reacting with chlorine gas. Okay, so let's look at the problem and then try to solve it. It's exactly 0.534 grams of platinum metal reacts with 1.35 grams of chlorine gas to produce platinum 4 chloride. Determine the limiting reagent, the theoretical yield, and calculate percent yield if 0.623 grams of platinum 4 chloride was produced. And we're also given the reaction. Platinum plus 2 chlorine gas yields platinum 4 chloride. All right, remember what I like to do is underline all the numbers that we have so that when we translate them, we're looking at the number and we're putting it directly to paper. So in this problem, what we want to do is we want to see how much of each reactant is made and how that determines our theoretical yield, because the smaller one will determine the theoretical yield. Platinum makes platinum 4 chloride. How much chlorine makes platinum 4 chloride? So let's start with the platinum. And if we start with 0.534 grams of platinum, we have to convert that to moles of platinum. Which is 1 mole of platinum is 195.08 grams of platinum, and then we're going to convert that to platinum chloride. So we go from grams to moles, moles to moles, moles to grams. You'll hear me say that a lot. You probably already heard me say a lot by the time you watch this video. So we have to look at the ratio of platinum to platinum 4 chloride, and that is a 1-to-1 relationship. So 1 mole of platinum 4 chloride equals 1 mole of platinum. So far we've gotten rid of grams, grams, moles of platinum, moles of platinum. Now we need to convert to grams of platinum 4 chloride, and I believe that number is 336.90 per mole. And now moles of that cancel, and we're left with grams of platinum 4 chloride. That comes out to be 0.922 grams platinum 4 chloride. All right? So we've determined how much we can make from the first reactant, platinum. Now we're going to determine how much platinum 4 chloride we can make from the second reactant, chlorine. So when we start with that, we take our number that we're given, 1.35 grams of chloride. And remember, chlorine's diatomic gas, which means when we do the molar conversion, which we're going to do right now, 1 mole of chlorine, it's this number. We'll start with 1.35 grams of chlorine gas. We'll change that to moles of chlorine gas, which is 2 atoms of chlorine for every molecule of chlorine. So we have to take that into account for the molar mass of chlorine gas. And then we're going to change that relationship to moles of platinum 4 chloride. And then we go back to our reaction, and right here we see it takes 2 moles of chlorine gas to make 1 mole of platinum 4 chloride. All right, and then we're going to convert that back to grams. All right, moles cancel, grams cancel, and we're left with grams of platinum 4 chloride, which come out to be 3.21 platinum chloride. So even though it takes twice as much, 2 moles of chlorine gas to make 1 mole of this, we still have chlorine gas in excess because we make 3.21 if we use all the chlorine at our disposal, this 1.35 grams, and we only make 0.922 grams of platinum chloride if we use the platinum. So this smaller number becomes our limiting reagent. All right. The next thing to find out, so we cross this out, is the theoretical yield. Well, guess what? this is the theoretical yield. If we use all the platinum 4 chloride from the limiting reagent, that's the theoretical yield. So 0.922 grams of platinum chloride is the limiting reagent and also the theoretical yield. So we can cross that off, which we did, and we can calculate percent yield, which is the actual yield over the theoretical yield times 100%. So in this case, we come back to our problem and we see 0.623 grams of platinum was our actual yield. Of platinum 4 chloride, I should say. And our theoretical yield from the limiting reagent of platinum that makes 0.922 grams of platinum 4 chloride. Oh, have to do the multiplication, don't forget. Times 100%, and that yields 67.6. Once you've calculated the significant figures, which in this case, all these numbers have 1, 2, 3, 1, 2, 3, and 1, 2, 3 significant figures. So our final answer are 0.922 grams of platinum 4 chloride, which is a limiting reagent because the platinum runs out before the chloride does. It's also the theoretical yield, 0.922 grams of platinum 4 chloride. Our actual yield was 0.623 grams of platinum 4 chloride. We divide that by the theoretical yield of 0.922 grams of platinum 4 chloride, multiply it times 100%, and we get a 67.6% yield, which is pretty good. Thanks for your time.